So, welcome back. Tonight's video is on fractions, so we've just started a brand new unit, or we will tomorrow in class, on fractions. So let's just talk a little bit about what is a fraction. And fractions are just ways of thinking about numbers in between whole numbers. So they're parts of a number. So if you look at, let's see if I can get this, here we go. Take a look at these red dots here. And if we count them, we've got 4 by 4, which means there are 16 of them. And then we look at how many of them are circled. So what fraction of the total number are circled? And I just count those. I've got 1, 2, 3, 4, 5. So we could say that, so actually I'm going to grab my pen from over here. I could say that 5 out of the 16 are shaded, so 5/16 of the red dots are circled. Okay, so that's one way of just thinking about, what are we talking about when we name a fraction? It's a certain number out of the whole. So what's important to remember is that you can't really have a fraction or understand the fractional part unless you know what the whole is, and the whole can change. So just pay attention to that as you're working through today's lesson. So I'm just going to scroll down here a little bit. So if we think about it, like let's say we have 20 counters, and that's going to be the whole set, and I ask you how many are 3/5 of the set. Okay, so we could start by going ahead and like pulling out 20. Okay, so I fast forwarded there, or put it on pause because you wouldn't have to watch me drag those out. So if I look, I've got these 20 counters right here, and I'm asking how much are 3/5. So let's first identify what would be 1/5. Oops, there we go. So I've got 1, 2, 3, 4, 5 equal parts. And I go, okay, so there's 1 out of the 5, and then here's 2 out of the 5, and 3 out of the 5. Then I can just count those. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I could say that 3/5 of 20 is equal to 12. Okay, and we just verified that by looking at it, a physical representation of it, and then just counting them. Okay, so what's another way we could solve that same problem? We could think about it this way. If I'm talking about 20 counters and I want to know what 3/5 is, I can say, well, first, what's 1/5 of 20? And so if I just think, what's 1/5 of 20? And so I can just go think about 5 times what number equals 20? Well, 1/5 of 20 equals 4, because 5 times 4 is 20. And then once I know what 1/5 is, all I have to do then is triple that number to get to 3/5. Because if 1/5 is 4, then 4 times 3 gives me 3/5, which is 12. All right, so that's a relatively simple problem, and I'm sure that you're going to do great on that tomorrow. Let's flip to the next type of problem, and this is sometimes a little bit more challenging. So, kind of starting from a different point of view or a different perspective. If 12 counters are 3/4 of a set, how big is the set? Okay, I'm going to pause it while I pull out some of the little circles for you. Okay, so I have 12 counters. And I've said that these 12 counters are 3/4 of some set. And we're trying to figure out how big is the whole set. So the first thing I'm going to do is look at this and go, okay, if this is 3/4, then I've got to find 3 groups. So 3 equal groups, this time would be right here. And now I'm going to ask myself, well, how many were in each group? And it would be 4. So if I just added one more set of 4, that should give me 4/4, or the whole set. And that would be 4 times 4. If I counted them all up, that's going to equal 16. All right, so I'm going to give you another way of thinking about the same problem. Again, going back to that use of the unit fraction. So I'm going to draw a line right here. Switch colors. Okay, so 12 counters are 3/4 of a set. How big is the set? Okay, so if I ask myself first, well, what's 1/4 of the set equal? And how would I get that? If I started with 12 and I want to know, what's 1/4 of the whole big giant set that I don't know what that is. That's the thing we're trying to figure out. Well, this is 3/4 right here. So in order to figure out what 1/4 is, I would take this number and divide by 3. And that's going to tell me that 4 is 1/4 of the full set. Okay, so 1/4 is equal to 4. Once I know that, how do I get to the full set? Well, in terms of fractions, what would be a full set? A full set would be 4/4, right? So 4/4 is exactly 4 times the amount of 1/4. So I would go this number, 4 times 4, which gives me 16. Okay, that's just another way of thinking about it. All right, so these are the kind of problems you're going to see tomorrow, and I'm going to give you a couple problems for you to practice on your own, and then we'll try it tomorrow. All right, so here are the 2 problems you're going to try on your own, and make sure that you put this in your Cornell notes. So if 50 counters are the whole set, what fraction of the set is 45 counters? All right, so going through this, remember that you can always use the unit fraction to help you solve the problem. And then the second problem, Zoe and Emily had gone for a 35-mile bike ride. By lunch, they had ridden 5/7 of the distance. How many miles did they have left to ride after lunch? All right, so again, use the unit fraction anytime you can to help you. You can go back and review the problems we did just before this to help you, and good luck, and I will see you tomorrow.